name's Heather Chluda. I'm going to be talking about our waste and trash reduction method for Mars and interplanetary travel. What I'm going to be talking about is composting, and composting with worms. Worms are not just used for bait, as you put on your fishing lures, or those slimy things that you step over after a hard rain. They do have a higher purpose, and that's called composting. And this could be a really beneficial tool that's low maintenance that we can use on our way to Mars. A little bit about composting. Composting is nature's way of recycling. It is the biological process of just simply breaking down the organic waste into usable soil and fertilizer that can in turn be used in our pop-up greenhouse that we're going to have when we get to Mars. And then we'll use that soil and turn it into more food, where we can grow more food and sustain ourselves. And so composting is a way to generate new life out of what would otherwise be just waste and trash that you just have to store somewhere and sweep under the rug kind of thing. And astronauts, once they get to Mars, will essentially be farmers. They're going to have to grow their own food to survive when they're going to be living on there for 2 years before their next return flight home. So there's some composting methods that we use here on Earth. And the first one is the aerobic method, and that just means you're composting with air. And use waste that's high in nitrogen, which is a lot of green matter, your grass clippings, dead leaves, that kind of stuff. You put that in a composter, and that grows bacteria. And it produces high temperatures up to 180 degrees Fahrenheit. And that quickly breaks down the compost, or that green matter. And it does not smell. The cons for this aerobic composting is that it's very high maintenance. Every day or two, you're going to have to turn that compost and aerate it in order for it to create the bacteria that creates the heat that breaks down the matter. Another method is the anaerobic composting without air. This is very low maintenance type of composting. It's just a pile, what we call pile composting. Essentially, you just throw things in a pile, keep adding more things to the top of the pile, and that condenses and compresses the material, and essentially no air gets in. This is, very low maintenance. Essentially, it just sits in a corner, you kind of forget about it. But the bad thing about that is that the waste takes 2 years to break down, and it creates an awful smell. So pile composting is what happens when you throw your food waste in the trash, and that trash goes to the landfill. These slow-working bacteria break down the matter, that organic matter, and it also often produces harmful chemicals. So you drive by a landfill and you have that awful smell. That's the ammonia and the methane created by this anaerobic type of composting. So what we want to do is more of a more simple type of composting. What I'm proposing is vermicomposting. So this is composting with worms. You get the best part of composting with air, that aerobic activity, but it's not that much maintenance, and it does not smell. So and this is most beneficial for composting food waste and paper waste, which is really what we're going to be mostly generating on the journey to Mars. Like I said, medium maintenance, so you only have to feed the worms once a week, and in small amounts at first, and then you monitor the worms and see how they're acclimating to their environment and the food that you're giving them, and you can add more as that goes on. It does require oxygen and moisture, so you're going to have to bring a little bit more of that on board the spacecraft with you, but you already have 4 living beings, astronauts, in the spacecraft, a little bit of oxygen and water to to feed the worms and make that vermicompost a healthy compost is really not that bad. So a little bit more about composting here on Earth. This is one of the vermicomposting items that you can buy just off the shelf, commercial off the shelf product. And it has these tiering systems. It's a very compact design, has, like I said, the vertical tier system. Up to 8 trays can be placed on top of each other. It's very lightweight. It's only about 14 pounds. You can even make it lighter weight too. It's easier to maintain. And like I said before, it does not smell. It's odorless. Unlike that landfill type of composting, when you're composting with worms, it does not smell, which is great. So this is a great way to have something small and compact. Just place it in the corner of your little spacecraft, feed the worms every once in a while, and you'll have rich soil when you get to Mars. So vermicomposting with worms, we're using red wigglers here on Earth, and they are the best candidates for breaking down organic matter most efficiently. They will eat almost anything you give them. And they in turn feed off the bacteria that's on the vegetable or in organic matter, breaking it down bit by bit, and they essentially poop out some worm castings, and that is that organic, rich, nutrient-rich soil that is nature's best manure. That if you've ever done gardening, you always have to add nutrients to the soil constantly if you just to make sure that your vegetables will grow efficiently and thrive. Well, using this compost, the worms make that soil nutrient-rich already. And what we in the composting world call that nutrient-rich soil is called the black gold. It's amazing. If you've ever made your own compost, put it in your garden, your vegetables just go wild. So these worms do need both green material, that veggie material, and brown. So they used tissues and paper products can be fed to them. So they have like a healthy balance of carbon to nitrogen base, where you get the nitrogen base is that green material, about 50 to 70%, and then the carbon base, that brown material, about 30 to 50%. And worms love to be in a colony. They thrive, being around worms like themselves, and they will double every 3 months. So after a 6-month journey, when you arrive on Mars, you'll have even more worms than when you started. And about 1 pound of worms is about 900 to 1,000 worms. So, and when, as we all know, in a rocket launch, every pound counts. You don't want, just 1 pound of worm can really devour lots and lots of trash for us. Now talking about how worms will thrive in space, and I took this little clip from Sesame Street. They're always great for learning. Worms in space. So we have had worms in space already. Worms have been on the Soyuz spacecraft. They've been on the International Space Station. These types of worms that they used were the C. elegans worms, and they are similar to the red wigglers. They eat bacteria, they live in your backyard, and they've not only been on this ICE mission back in 2004, but they were also flown on 4 other missions noted there, and each mission had great success in using these worms. And these worms in particular are very common and well studied in the biomedical research. They are Nobel Prize winning worms, very hoity-toity worms. But they are a model for human development and genetics and disease and aging. So they really model our own human behavior and biology. These worms live up to 2 to 3 weeks, and they have a short gestation period, so they are really great to have on board to see if they could produce and live and be happy in microgravity. And the results were overwhelming. They did live happily, they did reproduce abundantly, just the same as they were on Mars, or sorry, on Earth. So that's great. So now we know that worms can travel with us to Mars. And that first mission, imagine you are one of the 4 selected to go to Mars on that first mission, and you're going to be out there in the middle of space, and you look out there and it's just dark, and you're in space for 6 months. It's a long time to be in a tuna can with 3 other people that you may or may not always get along with. And there's no option for evacuation, no option for rescue, so you're essentially there on your own with no help. And on top of that, once you get to Mars, then you need to survive for 2 years on the Mars surface. So this is a very tough, mentally tough situation, not to mention the physical challenges that go along with that. So that's where these worms come in. They essentially can be your pets. You have this relationship with the worms. You feed them, they eat your food waste, and they're creating this nutrient-rich soil that you're going to, in turn, use to grow your food once you get to Mars. So you have this kind of relationship where you want them, you both need each other to survive. And the spacecraft going to Mars, since it is such a long journey, will likely have gravity, probably Mars gravity, simulated Mars gravity, and so you don't have to worry about being floating around and having worms escape and floating around the spacecraft with you. So the benefits of composting en route to Mars: it reduces garbage. It decreases the need for the trash storage. Otherwise, all that trash you would be producing, you just put it in a bag and probably store it somewhere in one corner. But here, you can, feed it to your vermicomposter worm bin, and they're going to break it down for you, and essentially you won't need to have that much trash. When I started vermicomposting 5 years ago, I went from a trash can that was like yay big to one that was the size of a very small, bathroom trash can. So it's amazing how much you can compost that you don't normally think about. And then, like I was saying, it creates that nutrient-rich soil that you're going to use to grow your own food. So that closes the food waste loop by returning food waste back to what you're going to have, a closed-loop spacecraft and habitat environment. And then, so that essentially grows new plants. When we're on Mars, the most important factor to remember is reuse, reuse, reuse. All the items that we bring with us, we have to reuse to their greatest potential. There's no supermarkets along the way. There's no street vendors while we're, going through the deep space to Mars. Composting is that great way to reuse our trash and make it into something for a higher purpose, growing more food. So essentially you're making something, in case, food out of nothing, or trash. Worms, like I was saying, have shown great success in living and reproducing in space. So they are great pets to have along with us. Vermicomposting takes about 2 to 3 months to get that first bin that you started full of composting and ready for planting. And like I showed in that tiered system, that tiered composter, you can have up to 8 trays working at various stages of the composting cycle, and you'll have that probably all 8 trays working by the end of your journey to Mars. And so while the astronauts are traveling to Mars, there's going to be a lot of downtime during that 6-month journey, and they need to have productive, enjoyable activities. And one of them is, feeding these worms and creating this nutrient-rich soil for their greenhouse garden. 8 trays. That 8-tray stackable system can support 3 to 4 astronauts, and you don't need multiple composters. Essentially, those trays are each one level or various degrees of composting within themselves. So as you stack them up, they get composted and decomposed over time just by themselves. The ideal temperature for worms is between 55 and 77 degrees. And I showed you that commercial off-the-shelf product that was lightweight plastic, but you can make it out of lightweight metal. And you can don it with heating units around it to keep the worms an ideal temperature. But worms are very resilient. They can survive between 40 degrees and 85 degrees. I've had, in Southern California, I've had up to 100 degrees Fahrenheit, and they still survived. I mean, you really have to take care of them and make sure their bedding is nice and moist, but they really can survive high temperatures. And like I was saying before, worms love to eat everything. Eggshells, grains, bread, vegetables, fruits, coffee grounds, and tea bags that we'll probably be using a lot when we're going to Mars, and dryer lint if we have a washing machine and dryer, and birthday cake. My worms like birthday cake. So they really do eat anything. And then that bedding material, the brown stuff, is the shredded paper, the used toilet paper, paper towels, any dead leaves that we have from plants, and that paper coffee filters that usually we just throw away. The worms all love to eat that. So there's a lot of things that can go into the composter to reduce our trash. And you need that good mixture of green matter and brown to keep those worms happy. Worm composting does translate easily to interplanetary travel. Because of those long trips, we'll need that simulated gravity just for us. When we arrive on Mars after 6 months, we don't want to be in microgravity. We don't want to be in 0G. And then once we land 6 months later, be expected to do, set up the habitat for living and surviving and thriving on Mars for the next 2 years. So we're going to want that simulated gravity, and so that will be even better for the worms. One trick I wanted to leave you with for composting is that freezing the veggies before putting them into the vermicompost really breaks it down more and allows the worms to start eating the vegetables right away. The worms like already decomposed veggies, overripe citrus, overripe veggies, or stale bread, all that stuff that they really love. So they're essentially eating the bacteria of the already decomposed veggies. And so by freezing the veggies, that breaks the veggies down even more and at a quicker rate. So one option is to use the airlock that we have already on our spacecraft. It's cold out in space. The airlock is usually cold. That's perfect for food storage, and we can use that cold to our advantage. And one lasting thought I wanted to leave about humans and worms. We can't overlook the psychological aspect of long-term living in space. Like I was saying before, these worms can be our pets. They rely on us to be cared for and nurtured and fed, and we rely on them to, have something to care for and nurture and feed and keep alive, not just, keeping ourselves alive and worrying about the dangers of, the numerous dangers of space travel. We can essentially take care of these pets and put our minds at ease, and that really will help in that essentially 3-year journey to and from Mars. So that's what I have. questions?
Am I right in assuming that these worms will take care of human waste? And the second question is, if a solar flare comes along, will they, I suppose they have to be protected just like we do?
Yeah. Radiation is obviously going to be a major issue for us and the worms. But essentially, the soil that they're living in is a protection enough for radiation. And your first question was about human waste. Yeah. So we do have, it is possible to compost feces. Usually we would do that in a separate composter, though. And not really with worms, it would be with other bacteria that would feed off. You have chemical composters like the ones out in the backcountry or out in the national parks that have that compost the feces a lot more efficiently than just worms. So you want to keep worms separately and human waste separate. Right. Yeah, they were produced so quickly.
Yeah, so radiation is most of it.
No.
Okay, fecal matter and your skin. How about urine?
Urine, yes, it could be part of the moisture that you apply to the bedding of the worms. Yes.
Has this been tested? Uric acid is pretty nasty.
It is, as long as you don't put too much. I mean, usually the uric acid can be put into the feces composter as well, and it breaks it down just as fast. But if if you're running out of liquid to keep that worm composter nice and healthy, then you can use that in small amounts.
Is there any sort of amount of heat output about vermicomposting? Like, could they use the heat as well, or is it basically because of the vermicomposting there's not much heat output compared to anaerobic?
There is heat output, yeah. It can get very hot with the green matter, like I was saying in that aerobic composting. When you have vermicomposting, you are aerobic as well. And so if you don't keep moisture and keep a lot of the brown matter and the green matter to a nice symbiotic relationship, then it can get super hot. And actually it has gotten up to 120 degrees in my composter and it killed some of the worms. So the worms can't survive in that heat, but it's still producing 80 degrees Fahrenheit, 90, compared to the outer space, it is heat. So it will be warming up the environment in the near vicinity.
Hi, Greg Hopkins. Listen, the obvious question that occurs is what do you do with the worms? And the obvious answer is the most efficient use is obviously to eat them. So this is how the revulsion that we all feel to eating our pets. Could you share with us your favorite recipe and tell us what they make?
Well, I always like chocolate-covered anything, insects, worms, whatever. But no, we don't have to eat the worms. If we do have too many of them, we can feed them to the other pets we might be bringing along, maybe say a goat or chickens or whatever. But really, the more worms we have, the better, because they are conditioning that soil and the garden that we're going to be using. You're going to put those worms right into the garden in your greenhouse once you get to Mars. So if they overproduce, it's not a big deal. They eventually, since they only have, a couple week cycle, they'll die, they'll reproduce. They kind of, make their own life cycle and kind of keep themselves in check.
What would you do if all the worms died in the ground?
If they all died, then that is all you have. You can't really grow anymore. Yeah, so really you have to train the astronauts to make sure that they will take care of them. And it's really, like I was saying, unless you have too much green matter and you forget to put the brown in, the temperatures will get high, and that's really the only thing that will kill the worms, really high temperatures. Yeah. Thanks.